Also, it's mostly because I wanted enough time to go over the things really that are on it. And I was like, it's not enough time. Okay, so we are going to finish up 4-1 today and potentially start on 4-2. Depends on how this goes. 4-1 though, sorry, 4-1. We're still talking about antiderivatives. I found my notebooks here. So I want to talk about one thing that Ashton asked me yesterday. So you could do something like this. So let's say f double prime of x is 2 plus nothing. And then let's say f prime of 3 is equal. No, we don't know how to do this yet. We don't know how to do that yet. We'll come back to it. Yeah. Is there stuff on it?
Yeah. David can erase the board. I could.
Okay. We will come back to that because we can't do anything yet. Okay. So the things that we were talking about yesterday are called general antiderivatives. Because with that plus c on there, that means that it could be anything, right? It's just in general, this is a general family of antiderivatives that we could have. Caleb asked, I think he asked a couple times yesterday, and I said it's coming. We can't actually figure out what C is sometimes. Okay, you have to have a little bit more information, but you can figure out what C is, and that is called a particular antiderivative. So a particular antiderivative will give you information to let you get C. So in this case, general and particular are opposites, kind of. General just indicates this is a very broad range of an entire family of things, right? And then particular means this is the specific one. I feel like I didn't hit the record button. Did I? Are you sure?
I don't know. I saw you did it.
Okay. So what that looks like is it would say, hey, f prime of x is equal to, let's say, this is going to be pretty easy, x squared plus 2x plus 1, and f of, let's make it f of 1. F of 1 is equal to 5. So you have to have the extra bit there. Okay, so it works like normal antiderivative. So go ahead and give me f of x. What we learned yesterday.
X cubed plus x squared plus a.
Okay, plus c, right? There's our general antiderivative. In order to find c,
Oh, you said you just roll.
we plug in 1 because that's our x value, and we make it equal to 5 because that's our y value. And that lets us get c. So in this case, we have 5 equals 1 cubed plus 1 squared plus 1 plus c. I made this easy for us for this first one. What does c equal then?
2.
So then, like, you're not done. It's not like, hey, I found c, that's the end all be all. Your goal is to find the equation. So your final equation is x cubed plus x squared plus x plus 2, because that's your value of c.
So if we're doing like both kinds, would it say general or?
It will say general and particular, and it will have to, like, it has to give you this, right? Otherwise you can't find it. So let's do, let's say we've got f prime of x is equal to 4x plus 5, and let's say f of x, nope, sorry, it's got to be a number, f of 2 is equal to 10. Okay, why don't you find me the particular antiderivative, please? Particular antiderivative.
Leave it as a decimal or correction?
Doesn't matter. Good question.
I got it. Do you need a decimal? No, you don't.
Okay. What's the, because you have to start with the general antiderivative. What's the general? Plus 5x plus c. Okay, got to find the antiderivative first. So you have a c, and you have somewhere, you got to plug in those guys first, right? Because this is f of x. So 10 equals, this is 8 plus 10 plus c, right?
Can we go straight to the 10 equals that if it's an easy one?
I don't care. So you get c equals what?
Negative 8.
-8. So final equation, f of x equals 2x squared plus 5x minus 8. Okay, questions on that? It's not hard. It's just the extra piece. Now we can talk about what I was going to do. This answers the question that Ashton asked me earlier. Okay, so here's f double prime. I'd like you to find f prime. Nope, I would not like you to find f prime. I'd like you to find f.
Oh, so you just do twice?
Yeah. Okay, so listen. If you do an antiderivative once on this guy, what's he going to be? What's he going to be labeled? Prime, right? It's going to be f prime of x would equal what?
2x plus c.
2x plus c.
Another c for this. So we got give a different variable?
You could, or you could just pause and find your c now. Right? Because you have the information for f prime.
Couldn't it be potentially two completely different numbers? Because couldn't f have another c, but wouldn't they be different c's? Like the c values would be different, huh?
Correct. So you'd have to use different letters. Listen, what you're talking about doing, like completing it, if you wanted to do it that. So what Garrett's saying is, could you just continue and not do anything? Yes. Yes, you could. You could say, all right, then f of x, what's the antiderivative of 2x? X squared. Okay. C is a number. So what's the antiderivative of c? Cx. But you would have to use a different c, like use a different letter. Mm-hmm.
Okay.
Let him in.
I won.
Let him in anyway.
I saw Mason this morning.
Hi.
Oh, he's got nursing.
Do you have a pass?
I think I'm absent.
Okay. Were you?
Something juicy going on?
No, I was in the middle of a surgery.
No, that is
Oh, that's going to be school related.
That classifies.
Yeah, but only if I tell Mr. Hansen. And I told him I was going to be missing from success, but I told him I'd be back in time for this hour. That's kind of.
Okay.
Oh yeah, that's my stuff.
So anyway, what you want to do is here, 2x plus c, you want to not do what Garrett did. Because then you're going to be like, how do I find this? Right? You want to go back here and plug them in as you go. Okay, so go ahead. I want you to find f of x for me, please. The particular equation for f of x.
I think Garrett, it's okay that they're two different values. Because they're not the same thing.
Because they're not the same number.
They're
Yeah,
both.
I know, that's what I'm saying, that they're not the same number.
Right.
So then we have to find both of them.
But you would do it one at a time,
Okay.
like with your f prime first.
So you have two separate c values.
Yeah. There we go. Alright, fine.
Sometimes will they not give us the f f in our final answers that time? Do they ever do that?
Oh, I didn't realize that you gave us F prime less than 3.
Which then would explain why your question.
Yeah.
Yeah.
Okay.
Okay.
That makes sense.
I don't understand what you're asking. Sometimes will they not give you what?
F. If it just ends at f prime, is can you have an answer?
Oh, sure. Like they might say, here's f double prime, find f prime.
Okay.
Just one step backwards, right?
Yep.
Okay, so up here, you have the information here. What is C?
1.
C is 1, right? So 3 equals 2 times 1 plus C. C has to be 1. So I know f prime of x is 2x plus 1. Okay, what's the general equation for f of x?
X squared plus X plus C.
Yep. Okay, and so then you have 4 is your f value, and this would be 2 squared plus 2 plus c. What's c? -2. So you do have, depending on how you run it, you do have 2 different c's, but you're getting rid of this one before you use the second one. So f of x is x squared plus x minus 2. Okay, you want to try one more of those?
So the C is the final one, and the one you find in the middle can just be like, do you have to name the C?
You name whatever you want.
So it just doesn't matter in the end. So
Doesn't matter in the end anyway, because you're filling in numbers, right? So it doesn't matter.
You could draw like a disgusting object and it would work. Like something horrifying. Wow. Wow.
I didn't think about that.
Oh, that's
Wow.
crazy, dude. I've done nothing. I'm sitting here silent.
Yikes, you guys being mean?
Yeah, they're bullying me with stuff. But you should
They.
not.
Hey, whoa,
They, you included. What?
It was
It's a
all
group
mine.
effort. They're all pointing at me and laughing right now.
It was all mine.
It's
all
all
that
else.
shit.
It was a collaborative effort between Miles
The
and
ginger
I.
either. I just wanted to say this.
Okay. Try that, please. I'm sorry, this is F, not F double prime. I'm looking for F of X. I'm looking for F of X. Final answer.
They probably wouldn't usually give us these with sign in them, right?
They could.
But they probably wouldn't usually, right? Because that'd be ugly.
It's not any uglier than anything else.
Well, what if they give a sign of a number that wasn't a nice number?
No, they would give you a sign of something that's a nice number.
Like signs like 3.8.
No, they're not going to do that.
Watch them do exactly that on the AP test.
And if they know calc, you should just know it.
What's the antiderivative of 2x?
Don't let Miles. It's funny. Because he's ginger. Nothing wrong with being an Aries. You know what I'm saying? Into this.
Oh, yeah.
Pacifist. No.
Can get big number.
Yeah, it's pretty big.
Mm-hmm.
How do you put an outbound?
Yeah, this part I don't do in my head.
There's functions and I did it actually.
I can do it.
You can do it, but should you do it? For a big number or a little one?
It's a large negative number, relatively speaking, compared to the ones we've been doing.
Here it was, here's.
Yeah, no, I'm not doing it in my head.
It's not, you stupid idiot. It just does it. Are there equations in the calculator that we see on something?
So
calculator like this one, do it.
I think that's a computer.
Like it will integrate.
Yeah.
You
got the rest of the
So like if I do 2x plus 4,
I bet the
it
computer.
will integrate, but it does not give you a plus c. Like it's very, I don't want to say it's limited, but it's limited. It won't find you a plus c at all.
The original exercise.
Wait, is that this? Do I get a separate?
Yes,
you do. Oh, I'm glad you asked because I got separate.
Ask where the heck you even get a
Wait, did
box
you
like
have
that?
birthday also?
Did
No,
you say
it's my
it's
birthday.
on
I know, you were on, David. I was
Two. Is that what it was?
What?
Is that what it
292. Birthday or half birthday? Yeah, half birthday. Caitlin, half birthday too.
Hey, me too, birthday.
No,
My
no.
birthday is, I think it already happened.
My birthday did happen.
Yeah, it definitely did. It's mine.
Let me half birthday. You want you were gone,
Mine?
or else I was gone, or something, or snow days. That's what it was, you guys. David was gone for his, and everybody else were gone, or there was a snow day.
And I never got a half birthday celebration, Douglas. This needs to be rectified.
Did you get a whole birthday?
No, my birthday's the day after the AP test.
Oh yeah, the May people, it sucks to suck.
Oh.
Okay, what's your final answer? Garrett, what do you got for f of x?
X equals 1/3 x cubed plus 2x squared plus 9x minus 188.
That's what I got. Okay. So when you do the first one, your f prime graph or equation is x squared plus 4x plus c. What do you get for c? You get 9. So that was a 9, and then you anti-differentiate and you get 1/3 x cubed. Tried to give you something that would divide so you didn't have nasty thirds running around. Okay. Now, a couple things I would like us to talk about. We're just going to practice some ones that might be a little bit weird. Okay, so
Explain how you got -188. I got -1.
antiderivative is plus 2x squared plus 9x plus c. Did you plug in 6?
I did.
This is 72 when you plug in 6. This is also 72. This is
I forgot
54.
the square on the 2. 2x squared. That's where it was.
Yeah, don't forget.
Okay, so let's talk about, we're going to spend the next couple minutes just talking about some wise strategies and what to do if it looks a little bit funny. So what do you need to do with this guy? No.
Gotta bring that X up.
You got to bring it up. Okay, so actually, I'm glad you said that. Natural log. This is the difference between this and natural log. Natural log is only when it's a single x. It has to be a single power to be natural log related. So if it's any, and that's, I'm glad you said that because I forget to say that. So then the antiderivative of this is no. -1/2 x to -2 plus c, because the power bumps up 1, and then final answer is back to the bottom.
If it's x to the -3, wouldn't then you subtract 1?
We're doing an antiderivative, an antiderivative.
If it was a natural log 1, could we just move the x up and treat it like a power rule?
Okay, so watch what happens. This would be x to the -1, right? So observe, I'm answering your question. Okay, bump the power up 1. No problem. You can have x to the 0 power. That's legal. But aren't we dividing by 1 over the reciprocal of our new power? That's why. Okay, Avery. Avery had his question, has hand up long ago.
What if it's chain rule?
What if what's chain rule?
Like the natural log, like couldn't it be a chain rule?
Just
Single power?
no.
No.
Okay. How about this one? I want you to do this one. I want you to find the antiderivative of that one for me, please.
Just rewrite it. So
the notation for this one, we can just straight up write
Equals. Correct.
So is this in the book?
Oh, yeah.
Okay, I was just, because a lot of times when we get packets.
Yeah, it's in the book. I just wanted to make my own.
Yeah.
Really, is what it comes down to.
No shade, I was just checking.
Yeah.
Change the way I review for stuff.
Understandable.
Because they have lots of problems in the book, and a lot of times if we have ones like this, then I already have done all the problems.
Right.
And that screws with me, because then I'm like, in the back of my mind, I know what goes to these, and I don't understand the process, I just have to answer.
Right. Okay. So, what's the antiderivative of this?
2/3 x 2 3 then.
I believe so. Plus C.
No.
Dang it. What do we have to do with this guy if we're going to do his antiderivative? It's x to the 1/2. Bump his power up 1. So there's where the x to the 3/2 comes from. But there's a 1 in front of here. So 1 times something is... Nope. Something times 3/2 is equal to 1. That's 2/3. Okay, 2/3 x to 3/2. Okay. How about this one? You see what you can do with it, and then I'll tell you what to do with it.
Bowling has to be at 9:50 on Friday. Where are they? Are they going to UP?
I think it's their tournament.
Miss Douglas,
What?
how far away is what you're doing?
Random. Half an hour.
Bro, why don't you run the bowling team? That'd be so fun. You just leave school in the middle of the day just to go bowl.
Gary, you can do that if you do golf.
Yeah, but you gotta be good enough to be on the travel side.
Yeah, that's not happening.
You wouldn't know much about that, Avery.
Yikes!
He doesn't practice in the summer, and I ask him to. He goes, I'm busy. And he might be busy, but he can still change plans.
Guess what? Do my math.
Yes.
Yes.
I'm looking at my little sheet that you gave us that you said it was weird.
What?
Kind of a bitch, isn't it?
Yeah.
Because I know my brain processes it.
Alright. We gotta use the absolute value you said, right? Absolute value,
But
right?
it's
You can't do it.
This is impossible.
It's not.
No, it's
But
not.
natural law is one.
That's the issue we just talked about.
Yeah, she said this is a natural log thing.
Did I?
No, but that's what I.
Is it
It's
yes,
not.
or natural law of this?
Now he's trying to
It doesn't have like 3 natural laws?
David, are you done with this problem, or are you just yapping to Avery?
I am done with this.
What do you
problem.
have?
This is 8.
What do you have?
I have the wrong answer.
Then sit there with your mouth shut. Don't distract other people. Okay. Any ideas?
3 natural log mix.
Plus
Yes.
C.
Yeah.
Plus C. That's what I was thinking actually.
Okay. So, yes, listen. Here's the argument that I heard, the friendly argument that I heard between Austin and Simon. Okay. If you listen to what I said earlier, I said 1 over x is the only time it's natural log. So they're talking about the fact that the x is on the bottom. And one of them said, but it's 1 over x. And the other one said, that's a constant, move it out in the front or whatever, right?
I don't think it was.
So that is actually equal to this. Avery, you should pay attention to what is going on in this class, not about what Garrett is doing. Okay? So when you have a number that's out there and you're like, I don't want, if I didn't have this number, I know it would be 1 over x, move. What you really are doing is moving the x into the number into the front of the integral sign, doing the antiderivative of the thing that you know, and then putting the number back on. It's like a multiplied constant when you're doing a derivative. You just leave it along for the ride and then put it back on when you're done. Like, for example, if we were doing the derivative of 4 sine x, what's the derivative of 4 sine x? Not the anti, but the derivative. 4 cosine x, because don't you ignore the 4, do the derivative of the sine and put the 4 back on. It's the same thing except an antiderivative. So if you're like, hey, I've got a random constant there that I don't like, move him. This is 3 times 1 over x, and so you're really doing this. Antiderivative of 1 over x is natural log of the absolute value of x. We talked about that yesterday. It should be on your purple sheet.
Is there gonna be a point where we have another, like unknown variable on the top as well as the x on the bottom?
Yeah, but don't worry about that until later.
Cool.
It's later in the chapter.
If you did the product rule with a constant, would it work out to the same thing? I mean, why would you?
Yes, because what's the derivative of a constant?
Zeros and then things go away.
Yes. Yes.
So with 1 under x, it will always be natural log of x.
Always.
The way we're doing it.
It's
It'll
long,
never-
always.
it'll
No,
never-
always.
So it'll never be like natural log of 3x.
No, well, okay. So let me,
When does one go on?
I knew what he meant. 1 over x. Okay, so this is a good question, and I want you to do this one to answer that question. Okay, I want you to do this one.
That's not me, that's all.
For these two examples. So for this one, just rewrite this. So you wrote here 1/3, you wrote 3/2. I would put the race out for
Okay, because this is the antiderivative. So this is the rewrite of it, and then this is the antiderivative.
That was my too.
Do we write the rewrite of it or the antiderivative?
Well, no equal sign here, right? This is just,
Yeah, that's, I
this
didn't
is
have
the
equal
same
sign
as
here.
that, right?
So this one's like, I'm just rewrite. This is just the rewrite.
This is the rewrite, right? This is the same. There's your integral sign. This is the x, and that's.
So can you just pull out the 1/3?
This is me just talking.
Okay. So that wasn't like where you. But
Yes, Joe.
No, it's definitely, you can definitely do that. Like, there's no equation to that.
To do what?
Take 1/3 out, because if you times 1/3 by 1 over x, it's still 1/3. 1 over 3x. Yeah.
Take out 1/3, x to the negative.
Okay, don't do that though. Remember, we just talked about that. It's never x to the negative 1 with the power rule because you can't do that. So what is this one?
There's 2 answers.
No, there's not 2 answers.
Natural log of x.
Absolute value of x plus c. Aiden, what do you want your other answer to be?
It's chain would be like
No, you tell me what you want the answer to be.
I was still working it out.
Mm-hmm.
Because I did the other way first. I did that one first.
Okay, listen. This is what people want to do. They want to write this because they're like, oh, that's on the bottom. Okay, but let's do the derivative of this. What's the derivative of natural log of 3x?
1 over 3x times 3.
What's that? What happens? It's 1 over x. So never ever can it be the chain rule because, or never ever can it be something in there to get a number on the bottom because the chain rule would always cancel the thing out. Always. Because of the way that natural log is and the way the chain rule is. So this has to be done this way. There's no option there. Okay, let's talk about question?
So that's a nice little cheat for the natural log derivative too, isn't it? The constants don't matter inside.
Correct. Move them out. Always.
Natural log and e to the x are the derivatives.
Yes. Okay. See this a little bit more than where we would go with, let's just see what you think about that one. This is, I'm just not gonna lie, it's a little sneaky. This is what it is.
Yeah, there's a reason why the boys aren't canceled.
Cannot cancel that because it's a plus.
Oh.
So this only did because we're talking about natural log. We will come back. This actually comes back around at the end of the chapter. So don't stress about it too much. Anybody have a guess? Yep.
Natural log 4x.
You start by pulling out a 4.
That's the final answer.
That's the final answer. Because
And you could with that.
it's natural log is 1 over the x thing. So you know that 4x plus 1 has to be on the bottom.
And then you do the chain rule of
The chain rule is, the 4 on the top is because of the chain rule. And so that's where it goes. It disappears into the nothingness of it came from the chain rule.
So I should not be right.
Don't worry about it. Like this level's not on the homework tonight, okay? When we will talk about this more when we get to it. So if you didn't like that, there are other ways to do that problem. Okay, we need to talk about, sometimes you have to rewrite before you integrate. Okay, so you might look at something like this. I don't really want to do all of the antiderivatives. I really want to give you some homework time.
Is it from the same sheet?
Yes and no. Okay, so look at something like this. This is ugly. Because what the heck am I supposed to do? That is not an x to the 1 power on the bottom, so this is not a natural log. Also, there's a bunch of crap on the top. So what the heck? You don't have a choice on this one. It has to be rewritten. And the way that you rewrite it, thank you, Natasha. You have to split this up. So when you have a single piece on the bottom, okay, a single term on the bottom can split into 2 fractions. You could do it if it was a double piece and split it into 2 fractions, but that doesn't ever help you.
You can't just move that up to the top.
No, well, you can. You could if you did something like this, Caleb. It would be this guy is x to the negative 1/2, but you would still have to distribute. So if you like that better than the division, you can do that. Okay, this then can be simplified, both of those, so that you can do the integral of them. What is x over x to the 1/2? Oop.
2x.
Okay, so think about this. What if you have x to the 4th over x to the 3rd? What is that? Just an x. What are you doing with those exponents? Okay, so what is this? There you go. That's x to the 1/2. This guy, you know how to do this one.
1 over x.
Yeah, that's what it is. Thank you. So he's x to the negative 1/2, right? So this thing here is equivalent to this.
So then we'd have to rewrite it and to do our equals.
And then you would have to do the antiderivative actually. So all this work is just to rewrite it.
Okay, and we have to rewrite it as a new one.
Yes, you have to do the integral.
Like the way we do with limits. You have
Yes. I got what you're saying. With the integral sign. Yep. Should be minus 2x to the 1/2. Plus 2. Minus 2. Plus 2. Plus 2.
Is there a C?
Nah, of course there is. Okay, so that's one trick that you can do. Let me show you this one. Again, you might be like, where even the heck? Okay, that doesn't help us. Okay, tangent big dog. Thank you, Caleb. Look at this can be rewritten. This is a sine x and a cosine x and a cosine x. Okay, this is honestly would be really sneaky to do to you, which I don't intend to do. What is sine over cosine equal to? Tangent. What's 1 over cosine equal to? Secant. Okay, now, then the antiderivative of that is secant.
That's awesome to do.
That'd be awesome. It's like a work, but it's just
is going to take like 8 years because I'm going to underderivatify everything and then rederivatify it to make sure it's the right thing.
Oh, heavens. Okay, try this one. This one goes back to the top one. Okay, so try this one and I will not talk you through it. We're going to talk about 2 more and then we'll be done. Caleb, you can do this one. You can do this one.
We just gotta make the x equal x to the 3rd of x. It's 3 over x. actually do the work, you know?
Then you got to actually do the work, unfortunately. Okay, so if you were listening to Mason, this is just like this one. I told you it was related to this. Split it up. So I wouldn't do this one on my own, but I will do it for you, right? Because you don't need me to do that. So if you split it up, you can divide there. So you have an x. And then you have a 3 over x squared, which I would bring that up. It's just 3x to the negative 2. Okay, then you can do his antiderivative. So what's the antiderivative of x?
1 half x squared plus.
Yep.
I got the other half.
Okay. Minus
1/3 x cubed times
nope. It's got to bump up 1 power. So it's negative 1.
Yeah, 1.
It's just 3.
And then when we move it to the bottom.
Yeah. Okay, so listen, remember with a negative 1, you're bumping the power up 1, so it has to go up 1. If you're not sure what the sign should be, stop here, do the derivative of that, and see how close you are to this. You're right on, right? Negative times a negative is a positive 3, so we're good, and that would drop to negative 2. So that's the correct derivative. It's the correct antiderivative.
Plus c.
Yeah, I'm not done yet. So 3 over x plus c.
Up to the second.
Okay.
What? No, the
What?
first one. The first
Oh.
one.
There we go. Okay. Let's talk about what if you have something like this. So notice we switched variables here, which I know you guys hate, but you'll see different variables on the AP test. So notice I switch variables. So this is a dt. So they just have to match. Okay. We cannot undo this. You have to expand it, correct? Yep. So t squared plus 1, t squared plus 1. So this would have to be the integral of t to the 4th plus 2t squared plus 1. We're not going to do it, but you would have to expand that. Okay, one more. And again, we're just going to talk through this one. We're not going to do the whole thing. Okay.
plus c.
I didn't do the antiderivative of it, but yes, don't forget that. Yes.
I'm still on.
Okay, Caleb. Okay, so you guys, Caleb has said something in that just reminds me that I want to say this. Don't forget to do the antiderivative, right? We get so caught up in, hey, I got this. Here's an answer. I did something mathematically that you forget that you have to actually do the antiderivative also. So final answer would be 1/5 t to the 5th plus 2/3 t cubed plus t. There's where your plus c comes on when you actually do the antiderivative. Mason, what did you say about this?
So I return that into x to the 1/3 and then distribute.
Yep. Okay, so you cannot, you guys, at this point in our mathematical lives, we can only do the antiderivatives of polynomials, so nothing with the parentheses like this, okay, unless on very rare occasions you can. Natural logs, polynomials, like I said, and some of the trig things. So you have to simplify it into something that you can do the antiderivative of. This guy would need to be distributed so that he would be a polynomial. So that's what you're watching out for.
Is that part of the 1/3 times x? Is that x to the 2/3?
No, because you add the exponents when you multiply, right? So like x squared, yes. So it'd be x to the 4/3 minus 4x to the 1/3. And then you would have to do the integral. Okay. So let me have you do the ones on the bottom of the paper that I gave you yesterday. So the bottom of the worksheet, you're going to do those ones. So 17 to 22. Those are particular antiderivatives. Okay. if you give me a second, I'll tell you gold star in just a second. And then, I don't need to give you too much homework here. I would like you to do in the book, it's page 287.
I'm doing this on a backup worksheet.
Oh, do whatever you want to do. Let's see. Nope, don't want to do that. Let's go 14.
No.
2021. Nope, don't want to do 22. 34. Nope, don't need to do that because we're already doing those. And 44. There you go. Okay. If you are Gold Star Club, I already made this pretty small, but Gold Star Club, you can cross off 18 and 21 from the worksheet. But I want you to do all these because this is a very minimal assignment on the bottom. So that's not much that you're getting rid of, but it's a little bit. Okay, there you go.
So how I'm doing it this time is Douglas, I'm doing half of them below the problem, so the other half right next to it.
You wouldn't drop the
Lovely.
class.
Yes, right here.
You were like, they might have less because kids drop the classes. You wouldn't have less than the start with. Why is this class size now?
Could be worse.
I just forgot.
I had to, well, I started, I did it once and I was like,